box of chocolates contains 6 soft center and 4 hard center chocolates. A chocolate is selected at random, and once eaten, not put back, a second chocolate is then chosen. Now, this part over here is just explaining how they are setting this out. It says, let S1 be the event a soft center chocolate is chosen on the ith selection, and HI be the event that a hard center chocolate is chosen on the ith selection. So selection I, there's only 2 selections, the first selection and the second selection, and all they say is if it's hard selection, a hard center, they put a H and then a soft center on which selection. So it explains itself when we go to the first question. It says deduce the value of P H2 S1. So if I have to say that in words, which you don't have to, but I'm just going to write it down. What's the probability of finding on the second draw or the second selection? So second selection are hard, given that on the first selection was soft. Okay, so that is what it means. So let's read it. It says the probability of on the second selection having a hard center chocolate, given that the first selection was a soft side. Okay, so if I had hard and soft, there were 6 soft, 4 hard, so in total there were 10. If the first selection was soft, it means there's 5 remaining. So what's the chances of giving 4? So given, so H2 means there is 4 hard ones out of a total of, there's now a total of 9, so that will be 4 in 9. So that's the first question. In the second question, they show the following. They say, or ask the following. They say construct a probability tree diagram to illustrate the possible outcomes. Let's quickly do that. So I've got 2 selections. My first selection, and then from there I've got a second selection with 2 different outcomes. So with my first selection, it can either be hard center, so my first either a hard or a soft. My second selection can be a hard or a soft, a hard or a soft. Okay, so the 2 just shows selections and what's the outcomes. Now I'll have to quickly move this down a little bit so that we can see a little bit better and it doesn't overlap. So what we have is they don't have equal chances. Okay, so on the first draw we have a possibility, the probability of finding H1 is there is 4 hard centers, so it's 4 out of 10, and there's 6 out of 10. Remember that this must add up to 10, so 4 and 6 is 10. On my second choice, if the first choice was 4, it means that I've taken one of those 4, and there will then be a chance of 3, but there will only be 9 left. There will still be 6 soft ones. Over here on the second one, if I have 6 and I choose one of them, the first draw is a soft, it means there's still 4 hard centers left, so that will be 4 and 9, because there's only 9 left, and there will be then only 5 in 9 left. Again, this needs now to add up to 9, and I've made a mistake. Nobody stopped me, probably because nobody's here. That is 6 out of 9. So let me just say this again. 3 out of 9, 6 out of 9, that must be 9 out of 9. and I have wiped this now off the face, so this also need to be 4 over 9, and 5 over 9 is 9 over 9. What will we have now? This will give us, if this is the root that's taken, so if it's a hard and a hard, that will give us hard center for the first and the second, hard 1, soft 2, this will be soft 1 and hard 2, this will be soft 1 and soft 2. Right, so there's my, done that. I can tick my box, I've done. The third question is, what is the probability that the first chocolate has a hard center and the second a soft center? So let's write that. You have to write, you can't just write a value. You say the probability that the first chocolate has a hard center and the second is soft. So we're going to start with the second. So the second soft, given that the first one was hard. So what is S2? So let's see, because I wasn't concentrating. Just going to quickly swap these two around. I'm going to say this is H2 and H1. This is S2 and H1. This is H2 and S1. This is S2 and S1. So what's the probability of, and I don't have to say given either. That's maybe why it doesn't make sense. We can just, it's the same thing, sorry people, that's the same thing. But I can just say the probability that I have a hard center what's the probability that the first chocolate, I could have kept it that way, and the second soft, so SH2 and S1. Same thing, so we're looking at this outcome. For that path, it have to be this one, and remember, and is multiplication, so that will give us 6 and 10 multiplied by 4 and 9. That gives us a total of 4 and 15. If it's a calculator active, you can just use your calculator to calculate that. On the third one, I say calculate the probability. Calculate the probability that either both chocolates have soft centers or both. So either have both soft or both hard. So it's this one or this one, both hard or both soft. So it's this or this. So let's write that in words. C, well that's actually D. What's the probability of having hard, both hard, which means hard 2 and hard 1, or soft 2 and soft 1. Okay, so what's the chances for that? Now remember, and is multiplication, so it's this root or that root. Okay, so all means 4 over 10 multiplied by 3 over 9, that's the first root. All is plus this one over here, which is 6 over 10 multiplied by 5 over 9. That will give us 12 in 90 plus 30 over 90, and if you simplify that, the answer will be 7 in 15.